The Lister JP4 is a 4-cylinder, water-cooled diesel engine known for its durability and efficiency. Built by Lister, it was widely used in industrial roles like power generation and pumping. Part of the JP series, it was developed under a joint product agreement with Ruston and Hornsby, allowing both firms to focus on different engine sizes without competing directly. Renowned for its reliability and long lifespan, the JP4 remains a respected legacy engine in stationary applications. The Fairbanks Morse 2-cylinder, 2-stroke diesel engine marks a key development in American diesel history. Shown at McFarland Ranch in Galt, California, it reflects the company's focus on durable and innovative power solutions. While Fairbanks Morse is best known for larger engines, the 2-cylinder, 2-stroke models were also notable for their design and versatility. A standout feature is the opposed piston design. 2 pistons share 1 cylinder, moving toward each other and eliminating the need for a cylinder head. This improves efficiency and durability. The 2-stroke cycle means each piston delivers power every crankshaft revolution, offering a strong power-to-weight ratio. Scavenging, aided by blowers or turbochargers, helps clear exhaust and draw in fresh air. These engines were used in stationary power, marine settings, and even GMC trucks. Though less documented than larger models, sources like Gas Engine Magazine confirm their use. Today, examples like the one at McFarland Ranch showcase early American diesel innovation and mechanical ingenuity. The Hornsby Oil Engine 100 HP, developed in the late 19th century by Herbert Ackroyd Stewart and built by Richard Hornsby and Sons in the UK, was one of the largest hot bulb oil engines of its era. Rated at 100 horsepower, it ran on heavy oil, which was safer and more economical than gasoline, making it ideal for agriculture, industry, and pumping. Its key innovation was the hot bulb ignition system, which vaporized heavy oil before combustion, allowing reliable use of difficult fuels. This technology laid the foundation for later compression ignition engines and marked a significant step toward the modern diesel engine. The Enfield twin-cylinder diesel, known as the Enfield 100 twin-cylinder air-cooled diesel engine, was designed as an industrial power unit rather than for motorcycles. While Royal Enfield is famous for motorcycles like the Bullet, their diesel motorcycle was a single-cylinder 325cc model made in India. The twin-cylinder diesel, likely built by Enfield Industrial Engines Limited, separate from Royal Enfield motorcycles, served stationary and industrial roles such as heavy machinery, generators, and marine equipment. Designed for robustness and durability, it featured air cooling for simplicity and easier maintenance, and the two-cylinder layout offered smoother, more efficient performance than single-cylinder engines. Enfield also made the single-cylinder VS1 diesel, but the twin-cylinder provided more power and versatility. Today, it stands as a practical example of the brand's industrial engineering beyond motorcycles. The Fairbanks Morse 15 to 25 horsepower tractor is a significant piece of early 20th century agricultural machinery produced by the Canadian Fairbanks Morse Company and likely based on the 1910 Model N design. It featured a sturdy single-cylinder engine with a low-tension ignition system, delivering about 15 horsepower at the drawbar and up to 25 horsepower at the power takeoff, PTO. Designed for both fieldwork and powering stationary farm equipment, its simple yet durable build made it reliable during the mechanization of agriculture. Today, restored Fairbanks Morse 15 to 25 horsepower tractors are prized by collectors and displayed at heritage events, highlighting the technological advances that shaped modern farming. The Meats and Weiss hot bulb oil engine was one of the earliest American semi-diesel engines developed by German immigrants August Meats and Carl Weiss in the United States. It was a two-stroke hot bulb engine, notable for its simple yet innovative design, and quickly gained a reputation for reliability and versatility. Unlike conventional spark ignition engines, it used a hot bulb chamber, heated externally during startup, to ignite fuel. Once in operation, the combustion heat kept the bulb hot enough to sustain ignition. The engine employed direct fuel injection, spraying fuel directly onto the hot bulb, where it vaporized and ignited. Additionally, it used crankcase scavenging to efficiently clear exhaust gases, ensuring smoother operation. Though technically a semi-diesel rather than a true diesel, it worked on the same principle of compression and heat for ignition, allowing it to run on a wide variety of fuels with consistent performance.
Well, I think I'll sit down for a while.
The Otto 5 HP water cooling pump, displayed at the Cool Spring Power Museum, is a key example of early engine technology. Powered by a robust 5-horsepower Otto engine, it provided steady water flow to cool stationary internal combustion engines. preventing overheating during prolonged heavy use. At cool spring, the pump runs under load, with the engine driving it via belt to circulate water through cooling tanks. This setup showcases the simple yet effective engineering of the 19th and early 20th centuries. Beyond its technical role, the pump offers an educational glimpse into how cooling systems supported reliable early engines, making it a living piece of mechanical history. Starting the 1924 Ruston Hornsby IP5 BHP engine involves precise preparation. Bearings, especially the big end, are oiled. The exhaust cam is set to half compression, and ignition is retarded. The mixture is set rich, and petrol is added through the priming hole. The engine is hand-turned until the igniter trips and fires. Once running, the exhaust cam is moved to full compression and pegged. Ignition is advanced, and the mixture adjusted for smooth operation. Richer once paraffin takes over after the vaporizer heats up. The McDonald Stype Energy Diesel is a classic Australian stationary engine built by A.H. McDonald and Company in Melbourne. Introduced in the 1930s, it became iconic for its single-cylinder design, powering farms, mills, and construction sites. Built as a heavy, slow-speed engine with direct injection, it earned a reputation for durability and fuel efficiency in harsh rural conditions. Named Energy for its power output, it drove equipment like pumps, sawmills, and lighting plants. Its large flywheels and steady beat made it recognizable, and it could run on diesel or crude oil. Today, it's valued by collectors as a symbol of Australia's industrial heritage. The Hornsby Ackroyd Patent Safety Oil Engine, developed by Herbert Ackroyd Stewart and built by Richard Hornsby and Sons in the late 19th century, was the first successful engine to run reliably on heavy oil. Its key innovation was a separate vaporizing combustion chamber, laying the foundation for hot bulb engines and directly influencing the development of the diesel engine. At a time when light petroleum fuels were hazardous to store and transport, the engine showed that heavier oils like kerosene could be used safely and efficiently. Its reliable combustion and resistance to clogging marked a major milestone in engine history. The large reciprocating saw powered by a Thomason 30 HP diesel engine represents a remarkable example of historical industrial machinery. Unlike modern handheld reciprocating saws designed for precision cutting, this machine was built for heavy-duty applications, often in sawmills or demolition work. Its robust construction allowed it to slice through extremely tough materials, including structural steel, masonry, and large timber. At the heart of the system is the Thomason 30 HP diesel engine, delivering reliable power to drive the saw mechanism. This level of horsepower far exceeds typical cutting tools, emphasizing its role in large-scale industrial operations. The machine's design reflects an era when mechanical strength and durability were prioritized over compactness and portability. Today, restored examples of such equipment highlight both engineering ingenuity and the evolution of cutting technology, serving as a testament to early innovations in heavy machinery. The Ranger V770 was an American air-cooled inverted V12 aircraft engine developed by Fairchild's Ranger Aircraft Engine Division in the early 1930s. First flown in 1931 and derived from the 6 to 440 series, it was most notably used in the Curtiss SO-3C Seamew. Produced from 1941 to 1945, 795 units were built. It remains the only American inverted V12 air-cooled engine to reach production. The Hornsby oil engine, developed in the late 19th century by Richard Hornsby and Sons of Grantham, England, was a pioneering internal combustion engine based on Herbert Ackroyd Stewart's hot bulb principle. It was among the first practical engines to run on heavy oil instead of gas or petrol. Its design included a separate vaporizing chamber where fuel was heated and mixed with air before ignition, allowing reliable use of low-grade fuels. Produced in various sizes, from portable units to large stationary engines for agriculture, industry, and marine use, Hornsby engines were known for strength, durability, and long hours of heavy operation. They played a key role in promoting oil as a fuel and laid the groundwork for diesel engine development worldwide.